Hi, this is Mr. T's Science. This series of videos on Mr. T's Science Exam Help are here to help you master your science exam. In this video, we're going to look at how to answer organic chemistry paper, achievement status 91165, level 2 chemistry, and specifically we're looking at adding potassium hydroxide to haloalkanes. The detail of this is when we add potassium hydroxide to haloalkanes, we can add it in two different conditions, dissolved in alcohol or aqueous. We're going to have to answer questions about this in detail to ensure that we get top marks in our exam. I'm going to go through this in this video and I'm going to help you master your chemistry exam. If you find this video helpful, don't forget to share, like and subscribe and look out for new videos. Hi, in this video we're going to look at achievement status 91165 exam. In particular, we're looking at the questions that relate to the addition of potassium hydroxide to haloalkanes. So the first example that we're going to look at here is from the exam in 2021. And remember, if you want a copy of this exam to look at as I go through this, just type in the details at the top right into your search browser and you'll be able to find the exam and download it, maybe print it off if you want to write on it. Okay, so this is question D. It's question 3, last question, last part of the question of the paper, and it says when potassium hydroxide KOH is used as a reagent, 3-chloropentane can undergo two different types of reactions depending on the conditions used. Okay, so let's unpack this. Reagent means it's a chemical used to make the reaction happen or to change the organic molecule. Here we're going to change a haloalkane to something. It says two different types of reactions. When we're talking about types of reactions, we're working from addition, substitution, elimination, acid-base, oxidation. So we need to know the types of reactions that happen when we add KOH, and the conditions they're specifically relating to: is the KOH dissolved in water, that is it aqueous, it would have a KOH AQ after it, or is it dissolved in alcohol? In that case it would be KOH ALC in brackets after it. So when we answer this question, we have to give account of the chemical processes that occur, and so it means we're going to give detail about what happens in the reaction. The conditions required relate to remember, is it aqueous or is it dissolved in alcohol? The structural formula of the product is something that we will work out when we go through. And the type of reaction, remember, is elimination or addition. Sorry, not addition, substitution. I had that a bit wrong. Okay, so the first one we might look at here is elimination reaction. So if I add KOH alcohol, it's going to produce an alkane. So basically you remember that alcohol does not produce the alcohol. So if it's dissolved in alcohol, it's not going to produce an alcohol, but it's going to produce the other type of reaction that it undergoes, which is elimination. In this case, the chlorine and adjacent hydrogen. Doesn't matter which hydrogen we take because they are both coming off the second carbon and we will get the same answer. So we're going to remove a chlorine and a hydrogen and construct a double bond where that has been removed, so produce an alkene. So the product we're going to produce here is going to be pent-2-ene. And to be specific, we would say we remove the chlorine and the hydrogen from the adjacent carbon, which was carbon number 2, to produce an alkene. Okay, and to produce this alkene, pent-2-ene. Okay, so what if we added potassium hydroxide aqueous? Well, this is the one that will produce an alcohol, so therefore it is going to be the substitution reaction. So in this case, the chlorine atom is going to be replaced by a hydroxy or an OH functional group, and this will become an alcohol. With the OH coming off the third carbon, it's going to be called pentan-3-ol. And we can draw this by just replacing the chlorine with an OH. We can draw it expanded like I have at the top in this form, or condensed as I have in the bottom. Now if we were to look at the marking schedule, you get a mark here for identifying the product, one of these products, correctly, or identifying the type of reaction that happens, that is the elimination when you add KOH alcohol, or substitution when you add KOH aqueous. If you explain one reaction type, So if you explained that here this is an elimination, you remove the chlorine and the hydrogen, and you gave a product, so if you'd mostly part the first part or the second part, you would be at a merit. If you fully explained, if you did all of that written here, and remember to give the detail about if you're doing an elimination reaction that the functional group and the adjacent hydrogen is being removed to make a double bond, or if you're doing a substitution saying that the functional group has been replaced. So if you put that detail in, you're going to get an excellence, and you need that for both of them. Okay, if we look at the 2023 question, there wasn't a question on this in 2022. So just on this small sample, 2 out of 3 times we'll have it. So it's good to be prepared to answer this question. So here they've got compound A, and it says it forms 2 different products from reactor with KOH. Now, because they've got KOH there, the first thing that we have to think about is, okay, we remember we only use potassium hydroxide when we have it as 2 different conditions. One dissolved in water, that is KOH brackets aqueous, and one dissolved in alcohol, KOH brackets alcohol. We have to compare and contrast these 2 types of reactions, talk about the conditions, that's just what I said, alcohol or aqueous. State the type of reaction. Remember, if it's an alcohol, it's going to produce an elimination reaction. If it's aqueous, it's going to produce the alcohol. And give the formula of the products. So we go through similar as we did to the other question. KOH alcohol is an elimination reaction where the Cl and an adjacent hydrogen is removed to make a double bond. We will say in this question, because it's at the end, there is only one option, one answer here, okay, because we only ever remove the hydrogen off the second carbon because it has to be adjacent. Produces an alkene pent-1-ene. Here it is, the structure. Remember, I could have drawn that out as a fully expanded, or I can draw it condensed in this form. The KOH aqueous, okay, if I add that reagent to this, it's going to substitute the chlorine here with a hydroxy group or an OH group, producing the alcohol pent-1-ol, and then I'm going to draw the alcohol that it would produce. And this here is our full answer. So when we mark this, if we talk about there are 2 different conditions, KOH alcohol, KOH aqueous, which they didn't tell us, they give us an achieved. If we had one of the products correct, they would also give us achieved, but only an achieved for one of these ideas. If we correctly link the condition of the product to the reaction type, so if we said KOH alcohol was elimination, for one reaction we get a merit. Okay, that seems pretty straightforward, pretty easy, that one. If we elaborate upon the reactions of KOH with reaction types and products, so if we actually do the full thing here, then we're going to get the excellence. Okay, so we're going to say we need this for an elimination, KOH alcohol for elimination, to produce this product. We're going to link them all together. We'll get this first paragraph, and then the second one we need as well to get the excellence. Look, don't be afraid to put the extra detail in, like explain how an elimination reaction works, that we remove the functional group and adjacent hydrogen to produce a double bond, or the substitution that we replace one with the other. Putting that detail in is often used as a threshold for excellence, even though on the marking schedule they say that it is an excellence to do something simpler. Okay, I hope this has helped. If you want any more help with the exam questions for chemistry, don't forget to look at my other videos. Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers, and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.